GM everyone, it's Mel here from Double Club, and today we're gonna do a quick tutorial on how to get started with Coinbase's Wallet API version 2. In case you don't know, Coinbase has just released its latest version for the Coinbase Wallet API, and it's very cool. It does some changes to the previous version where we have a lot more access as developers to new methods without having to handle a lot of the complexity of the blockchain, setting up the client, setting up communication with the blockchain, checking balance, getting access tokens or tested tokens so we can start sending transactions, or just making it easier for developers to get started without having to handle all of these layers. It actually abstracts them for us, and we just use them as an API or using the SDK. One of the coolest features, as you can see here on the documentation, is that they're also using a trusted execution environment for the private key administration, and just in general providing an extra additional layer of security where we have a trusted execution environment where the important sensitive information such as private keys and signatures are generated without allowing access to any other entity. So this works like this. It's all being using an AWS service for the trusted execution environment, and as we can see here in the documentation, nobody can access this environment, not even AWS, Coinbase, or ourselves as developers. And the way that it works, we're gonna be using our Coinbase developer API keys, which we do have access as developers, but only for the request authentication. Once these requests get to the EC2 instance, which is a virtual machine, it accesses the trusted execution environment through virtual communication, like VSOC. These are methods that are used within virtual environments. However, this trusted execution environment is not accessible, as in there's no way to check what the information is happening inside of that. And the only thing that gets extracted is the encrypted information. And in order to unencrypt it, unencrypt private keys, unencrypt information relative to the account, maybe naming and other features that Coinbase may develop in the future, they will need to have your developer wallet secrets and your API secrets and your key in order to unlock this inside the trusted execution environment, but nothing else is going to come out of it. The only thing that's going to come out is the transactions that are requested once they are signed inside the trusted execution environment, and this way we make sure that no information, no sensitive information is exposed, and we only return the result without exposing any of the private keys. So this gives us a way better security instead of other type of services such as multi-party computation, where we don't know. In multi-party computation, you have a distributed set of shards for your keys, but if somebody gets control, or an entity gets control of the majority of these shards, they can sign transactions for you. So instead of, it's an additional layer of risk. Instead of trusted execution environment, which is all handled inside a simple environment that nobody else has access. So returning to our documentation, we have other information here. I suggest you take a look into the docs. This is an alpha version, so we're gonna be diving into the first methods that we have available. I'm sure the more and more methods are gonna be released as the time goes by. Right now, we will be focusing on the quick start guide, so we can show very easily how us as developers can create accounts via the SDK. We can also list all of the accounts that we have created through our SDK or the portal with our API keys. And we will also be able to request testnet tokens for Base Epolia in this case, for any account that we have created, or even any account that we want. And at last, also, we will be able to send transactions from the accounts that we create to any other account. We will be sending testnet tokens on Base Epolia to another account. So to do this, we're going to go to the quick start. And I'm also, I want to show that we have created this web application starter, because the quick start, while it's very illustrative and it shows us how to get started very quickly, it's all scripts. So what we want to show a little bit further is how we can, as web developers, start accessing this SDK and using it within our applications. So we created this this repository, which is a Next.js application, and you can scan this QR code, or you can go to the URL and clone it. I have already done this, so I'm going to move into the code right now, and I want to show that once you clone it, the first thing that I suggest you to do is take a look into the .env.template file, because you will need for sure these three variables. These three variables are available through the Coinbase developer portal, which we will see in a bit. And I will also suggest you to have any kind of RPC service just for accessing the account balances and such. In our case, we're using Alchemy, but you're free to use any other, such as Infura or Blast or Anchor. So let's go back to the documentation, because on the quick start, one of the very first, other than the requisites, we also have the create keys part. So we click here in the create a CDP secret API key. This should open your Coinbase developer platform. In my case, I have already logged in, and I already have several APIs over here. Actually, let me create a new API key for this tutorial. CDP wallet tutorial. I'm not gonna put any restrictions. One important thing is for you, once you start creating the API key, make sure that you enable the transfer option here, because this is the one that we are gonna need in order to request faucet tokens. Maybe the request faucet tokens is not needed, but definitely for sending transactions, so to initiate transfer of funds. And let's create and download, and it's going to show us a couple of it's going to show us, I'm just going to close this. So I'm not going to create it myself, but you should be able to actually create it, and once you create it, you will be able to get a couple of variables. So the first one is the key ID, which is the one that goes into the API key ID variable. The key secret should be shown to you just once, so make sure that this API key secret, you save it somewhere safe. And lastly, the wallet secret is one that is only shown once whenever you start using the wallet API. Myself, I have already created this, so I cannot show you how to create this, but make sure to follow the steps in the documentation here in the generate a wallet secret, because that's the one that's, as you can see here, oh nice, seems that you can actually generate a new secret. That's very cool. This wasn't available until very recently. But anyways, here's where you generate your wallet secret. As well, we will need it for our .env variables. Myself, I have already copied them into my .env.local file, so I should be able to go and use the CDP by myself. Now, a couple of things that I want to show from our application. We will be focusing on two main sections of our Next.js application. The first one will be in the API routes. I have created this Coinbase folder where we are storing 4 routes, similar to what the documentation states. We have a create an account route. We have a fund account with test funds, a send transaction one, and also another one to list all of the accounts that we have created with our SDK and our specific API key. So right now, what I want to show is, once you create your API keys and you store them somewhere safe in your .env files, you can go ahead and, if you are using our code or just following the tutorial, make sure to install the Coinbase CDP SDK. In our case, we are using Bun, so we did Bun add Coinbase CDP SDK, and I can show you here that our package.json has already installed it. So we already have it installed, and we will be able to use it and instantiate it. Anytime that we want to run our CDP, any CDP method, we need to instantiate a client. You can also instantiate one and start importing it in your files. Just anything that is comfortable for you. We will be doing it for each of our routes. And the first one that we are going to be actually using is not this one for creation. We are actually going to go and implement, instead of create, we're going to implement the account listing. So we're going to fetch all of the accounts that have been created with our CDP API key. If you're familiar with Next.js, or if you're not, the way that API routes are managed on Next.js is you just create a folder and you create a route.ts file, and the method that you want this API, like a REST API method in our case, we're going to be getting or fetching the listing, so we will need the get function. And now we're going to instantiate our CDP SDK, and we're just, Cursor is doing most of the job here for us, already suggesting what we need to create. And I'm going to put this here, but just we need to import the CDP client, which we have already installed in our packages. And just make sure that you are using the correct variables in our case, because sometimes like right now it's not actually importing. Oh, actually it seems like it did. Just a comma, and there we go. And yeah, actually it already suggested us the method that we need. So once we instantiate the CDP client, we access the .evm property, and we access the list accounts method. And what we're going to do here, actually, the response, how it comes, it actually, if you, it's not shown here, but you need to send the CDP response.accounts. And on our front end, this is the second part where we are doing stuff, and we will be showing everything that we are building. The first one is the accounts page. So if you, actually, you should come here and install the packages. Just some code that I had run before. And once you install them, you can start the development server. And on our localhost 3000, we should be able to start our application, and we will be doing everything here in our accounts page. And right now, here we go. This is because I already implemented the route, so everything is already connected. In our case, the method that we are running on the front end to get these addresses or these accounts is over here in the line 24. We're using Tanstack query just for better developer experience. But as you can see here, we are communicating with our API endpoint, API / Coinbase / wallet API / accounts, and we extract information from the response as data accounts. And I'm just using this interface just for TypeScript purposes. But in short, we are getting these data accounts, and we are displaying them here inside this table, just exporting the information. And this is what you can see. And that's the first part of our front end. And now for the other methods, we're going to we actually created a new page for each individual account that we have created. So if you click on any of these accounts, once you start creating them, you will see this account page where you get the wallet address, you get the current balance, testnet ETH on Basic Poly in this case, and a couple of buttons that allow you to request testnet ETH and send ETH. But of course, these ones will not work right now because we haven't implemented this functionality in our backend. We need to do that. So before doing that, we will connect our create account button with our backend. And our backend doesn't have the implementation. I just want to show you very quick. On our front end, we are using, once again, Tanstack query. This time I use mutation, which is kind of posting something into our backend. So that's what the mutation function is. We are communicating with our backend using fetch API. Actually, should probably do this async await. And we are communicating to our route which is located in the accounts /create, sorry. And we can see here that we have created this route beforehand. That it's just empty. There's no implementation. We're just getting this account just a placeholder value. And once we get that, we will be posting what the account is created. If we click here, of course, it's just sending not format address because we don't have anything connected. But let's go to our route and implement this. And just gonna be doing a quick dive into the documentation just so you can see how easy it is to create a new account. You just need to instantiate the CDP client and then access the method create account. So let's go ahead and do that. Let's just do, yeah, I didn't even have to do anything. So Cursor did all of the heavy lifting here. In our case, we are once again instantiating the CDP client with our environment variables, and we are accessing the cdp.evm.createAccount method, and that should be good to go. This route is already connected to our front end. Remember, we are in the Coinbase Wallet API accounts create, and if we check the button that we have here that says create account on our front end button, create account, which is this one, it's already connected to this function called handle create account, and this is the one that's using this. It might feel like a lot of code, but it's just accessing this create account function that is communicating to our backend. And we will click it now, and we should be able to see that a new account has been created, ends with 9F9A, which is here, and perfect. We see that we have 0 ETH, but the account has been created. So now we want to then request some testnet ETH so we can send transactions from this account that we just created. I'm going to save this, I'm going to close everything, and what the documentation says is we need to implement this functionality. Instead of, following the documentation, we are going to skip this step of creating a new account because we already have an account here, and we will be using this account to request the testnet ETH. So we will be using that address inside our request faucet method, keep the same network, same token, and we're going to do a little thing to make sure that we show back the transaction. So now we're going to go to a request testnet ETH route. Once again, this route has been created beforehand, and we left it to do implement testnet ETH request here. For us, also, since we will be using the backend that Next.js provides us, we are using these search params because we will be sending, in order to instruct the SDK which wallet we want the testnet tokens to be sent to, we will be sending this wallet address as a param inside our button. So let me share once again how it looks inside. Here we have a new component called account data, and this component also is using this request faucet button. And inside this request faucet button is where we are communicating with our API endpoint. Once again, as you can see, is the request testnet ETH endpoint, but we are also adding this search param for the address because we will be sending this address in our endpoint call or API call to get this information on our route, on our backend, so we can instruct the SDK that we want this address to be sent the testnet tokens. That's pretty much what this block of code is. This is small validation to make sure that we are getting an address and the address is a valid address. After that, we will remove this to-do thing and instantiate once again our CDP client. And now we need to import the CDP client once again from here. Perfect. And we're gonna just copy and paste. And you can see here that the faucet response has a transaction hash property. So we are actually just going to destruct that from the request faucet method, and that's the one that we're going to send back. Now, a small thing, as you know, since we want a little bit of interactivity, want to show once the user requests testnet ETH, we want to show that the balance is updated. We have created a small part of code that we refetch the account balance once we get a successful call here. But in order to request a refetch once the transaction has been accepted by a block, we don't want to just send a transaction hash because that's just generated once we do the request, but that doesn't mean that the transaction has actually been accepted by the EVM. So we're going to do a small trick here. I know this is like maybe trying to be too fancy, but we're going to create a public client from using Veeam's methods here. Veeam is an interface, TypeScript interface to communicate with the blockchain. So we will be creating a client for the basic Polya blockchain where we will send this transaction hash and just make sure that this transaction hash has actually been received by or accepted by a block. And once we get that, we will actually send this transaction hash back to our front end so we can actually do the refetch balance and show. Why? Because if not, for example, just gonna do a very quick show here. If I go and do the request testnet ETH, everything's gonna happen correctly. see, yeah, we're getting back the balance, but it's still not very reactive. So if actually we check the base scan and we check, excuse me, so you see it updated, but it updated until later, so it has 0.0002. But what we're doing here with this is we are actually enabling our front end to wait for this transaction to be accepted, and it now you can see it updates better. It's just better user experience. That's what we have right now. And lastly, to send Ether, we will need to create, or rather modify, our send transaction one. The send Ether button, it's actually going to open us a model. So this one is on this component called send transaction button Coinbase. And as you can see, once again, we're using Transact query for the mutation, and we are communicating to our API endpoint, which is the send transaction one, and we will need to send 3 params inside our URL. So first one is going to be from address, similar to the previous one where we request the testnet ETH. We're going to be using the same address that we have here. We will be allowing the user to enter an address here, which will be taken from the address input in our model, and lastly, the amount that the user wants to send. So that's what we're going to be using on the front end. Everything else is just pretty much front end components. You feel free to take a look and check if that how's the implementation on the front end. And on our back end, we have something similar to what we had on the request testnet ETH route. Search params once again. As you remember, we are sending 3 params instead of 1. We're sending the from address, the to address, and the amount. We are also setting a small amount in case that the user doesn't send anything, just to make sure that we are sending something. We are doing some validations once again for the addresses, make sure that they are valid addresses. And now for the implementation. So once again, we instantiate our CDP client, and this is something that we are going to be doing different than the documentation. The documentation here instantiates a wallet client with Veeam. For this tutorial, we're actually going to use the Coinbase, the wallet API's send transaction method, and the way we access it is going to be very similar as the previous one. Remember, whenever we're doing transactions, the Coinbase SDK returns a transaction hash as part of the response, so we are destructuring it. Already, Cursor has accessed the send transaction method here, but it's not the same as the previous one where we were requesting testnet tokens. Right now, we need to create a proper transaction according to the SDK. There's no documentation right now on the website, but it's not very hard. If we enter control space, we can see that it's asking us a couple of things: the address, the network, and the transaction. So the address for this one, we're going to be using the from address, and then we will be creating the transaction. Since we will be doing just sending the native token for Base Apolia, which is ETH, we just need to enter the to address and the value and the network. The value then is asking for a begin, so we will be using, you can use begin, of course, but I prefer to use parse ether utility from Veeam. I just like it. It's the same. You could say it's the same function, but just I'm more used to using this. And once again, this should work. This is actually going to do a transaction sending a transaction. But once again, we will be implementing the public client thing, just so we have better UX. So it actually shows us the transaction hash on the model. And lastly, we will await for the transaction hash. Perfect. And we need to remove the default value that we had set. And once we do that, if we go and click here, send ETH, I'm going to send it to this address that I already have over here. And I'm going to send, actually, give me a second, how much do we have? We have 0.0003. So I'm going to send 0.00005, and let's see what's happening. Seems like we had an error here. Valid to address. Imported, it's not a function. Let's take a look into our backend and see what's happening. Post pay from address is correct. To address seems correct. The amount seems okay. This is strange. Doesn't seem to give us a lot of information. Let's see if we can take a look at our response. Seems to be a webpack error. So let's try again. Send. Maybe I was using too much. Okay. Seem to have something here. HTTP. Okay. Okay. This is the problem. I'm importing HTTP from the wrong package. Should be from Beam. My mistake. This should be working now. Send. Perfect. Now we are running it correctly, and we're waiting for the confirmation. Everything's happening on the back end, and now we can take a look into the Explorer, and we can see that we have sent successfully. Actually sent 0.0001 ETH to the correct address. That's fine. Seems like it didn't get this amount. Well, we can try again. Let me refresh over here. Let's try again. Send ETH. All right, and okay, now it caught the correct value. As you can see, for some reason the previous one it went to the fallback value that we had here on our route, the 0.0001. That's why we put it there, so we can just show that a transaction actually goes on. But anyways, we can see that the transaction is being sent correctly this time. And this is the tutorial. As you can see, we are able to create accounts very easily. We have a lot of accounts here where we can actually request tested ETH. We can actually send ETH from each account, and everything is handled on behalf of our users. Users don't have to do any kind of signature. They don't have to manage any of their wallets. Coinbase is still this wallet API. The version 2 is still on the alpha release, so we will have a lot of updates probably. We will have more and more goodies given to us, which will improve our experience. But the most important part is that we are handling this, or rather, this is being managed for us, and so we as developers can actually make it easier for our users to start using the blockchain, start using transactions, start storing information on the blockchain, and just making it easier for them to handle digital assets. I hope you like this. Once again, I'm Mel from Double Club. And one last thing that I want to share also, if you have any error, a couple of things that happened to us while building this workshop or this tutorial. We had a couple of 404 errors. In case that you get something like that, remember on your Coinbase developer platform, make sure that you can edit and enable this initiate transfer of funds option on your API specific restrictions. And if you have any issues with this kind of 404 resource not found, you can also visit the Coinbase developer platform Discord. I suggest you go over there in case that you have any question. The Coinbase developer platform team is very active. There's a wallet-API channel specific for the wallet API, obviously, where that you can send your questions, start threads, and if you have any question, feel free to contact us at Double Club, of course, or the Coinbase developer platform team. Once again, I'm Mel from Double Club. Hope you like this, and let's keep building.